So when it comes to fish food, it comes in a lot of different forms. There are flakes, there are pellets, and all sorts of other varieties. TetraPRO are known as crisps. What are crisps, and why is that any better than flakes or any other type of food?
So when we formulated TetraPRO, it was sort of trying to take fish food right back to first principles, really. And before sort of explain what crisps are, I suppose it's useful to have a quick look at what flaking is and how we make those flakes in the first place. So the flaking plant at our feed mill in Germany. What you can see on this image here then is we've got these large rotating drums, and these are heated. They're heated to about 130 degrees C. So this is a very high temperature process. So we've got this sort of initial mash of feed, and different flake colors will have a different, obviously a different mash and on a different cooking plant apparatus. But once we've got this sort of wet slurry, if you like, that then is sort of semi-sprayed onto these really hot rollers, and it's then cooked very quickly. So we've got this really thin film of food which is cooked on the rollers, and then as the rollers keep turning, we've then got this sort of wet mash has then gone into this very sort of fine sheet that is incredibly brittle. So as this fine sheet is then rolled off towards these knives here, it's then broken up into fragments, and we've then got these these flakes which can then be mixed. The different flake colors can be all then mixed together, and lo and behold, we've got tetramin. Crisps are made in a totally different way, and it's made by a process of extrusion. And extrusion is a way of, lots of animal diets are made through extrusion, but then also so are lots of crisps that we eat, as in, a packet of crisps, Wotsits and Ringos and other crisps are available. Breakfast cereals are going to be made in that same process of extrusion. And extrusion is just a sort of a superior way of making a food compared to flaking, or if we're comparing it to pelleting, where sort of compression steam pelleting, where that mash just would have been pushed together under high temperature. The way an extruder works, as we can see here then, is you can have twin screw or single screw extruders. We use a twin screw extruders because they give us those two-tone crisps where we've got a round crisp with a spot in the middle of it, and the twin screw extruder helps us to do that. But what the extrusion process is doing is getting that sort of mixed food where we've got all the ingredients that have been all milled down to a small particle size and mixed in what's just essentially a massive great Kenwood chef, if you like. But once that mix of ingredients then goes into the extruder, the screws, as the food then gets turned around by the screws, we're getting much better mixing of the ingredients inside those screws. And as the food works its way down through the extruder chamber, as it's being forced down by the screw, we're getting better mixing. We're able to then get cooking at a lower temperature, as we use in here. So we're not using such a high temperature. So that makes the ingredients so much more accessible to the fish. What happens at the end of the extruder chamber then is that this food is then pushed out to a die, and then we can have that die any shape we like, because you think of all the different shapes of cereal. My kids eating multi-grain shapes or whatever, they're just different grain mixes, and some come out fish shaped and cross shaped. That just depends what shape you've got in the die there. And obviously as the screws keep turning, they're forcing that mix out through the die. So it's just a superior way of processing foods, and that then gives us these crisps. So we've got this sort of sausage coming out through the die. All we finally need then is a knife rotating to keep cutting off the shape, and then we've got what we want. Crisps are then coming out as little tiny pellets, and those pellets are then rolled flat, and then lo and behold, we've got a single uniform size crisp. One of the problems with flakes is they're being so brittle that we get lots of different sizes of flakes, and some of them, if they're being shaken around in the pot a lot, we can end up with quite a lot of dust in the bottom of the pot. A crisp is so much more stable. Part of that stability comes from the interaction of starch, the starch ingredient in the food. That starch is gelatinized. It's turned into a sort of a jelly better by extrusion. And that gelatinization of the starch stabilizes the pellet or the crisp or whatever we're making, first of all. So we've got a much more stable structure. If you're having a bowl of Cheerios, those Cheerios can sit in the milk for a long time and they retain their shape due to that gelatinized starch around the end. We want that with a fish food. We want to put it into the water and we want it to retain its shape until it's in the mouth of the fish. And it's then got those teeth and pharyngeal teeth grinding that pellet down. We want it to break up in the mouth of the fish, not in the water. And extrusion helps that process. But also the starch gelatinization renders that starch much more accessible to the fish. So extrusion is an utterly different process of producing the food. Another really important thing then is that it is a lower temperature production process then. For us, we are extruding our extruded diets are being cooked at 75 degrees C. Those flaking drums are at 130 degrees C. The more you heat an ingredient, the more sort of things like vitamins, heat labile vitamins can be lost from the food, for example. So we've just got the nutritional profile of the food is superior when it's cooked through extrusion due to that lower heat process. So this twin screw extruder, which gives us two coloured sticks or crisps, that's a process that is patented to us in Tetra. So it gives us two formulations in one in a highly stable, highly nutritious particle for the fish. So that's how sort of crisps are better than flakes. It's right back to the manufacturing process, ultimately depending on extrusion rather than hot drum flaking.